Right, we're going to be looking at some basic trig equations today. I'm going to start off by solving each equation in the first four quadrants, in other words, for an angle between 0 and 360 degrees, and then from there I will generalize that to the general solution. So this pink cast diagram that you can see on the top right is incredibly important to learn off by heart. So notice at the middle you've got your ASTC, all stations to Claremont, if that's your little rhyme to remember it. And the A, S, T, and C stand for which quadrants the different trig ratios are positive in. So the A in quad 1 means all your ratios are positive in quad 1. S for sine is positive in quad 2, cos and tan are negative there. Quad 3, T means tan is positive there, sine and cos negative. And in the last quadrant, for the C, cos is positive in the fourth quadrant, sine and tan are negative there. And those I would suggest you just learn this cast diagram off by heart. It's important to know. Okay, so we're going to start with a very, very basic equation. Sine theta equals negative 0,3. Now, the first thing I need to do is find my reference angle or key angle. This is not theta itself. This is just an acute reference angle. To find this angle, you're going to press Shift sign on your calculator and enter 0.3. Now ignore the negative. The negative will not help you find your angle. It will only dictate which quadrants we look at. So I went Shift sign 0.3 on my calculator, and I'm going to go to 1 decimal place here. It's going to give me 17,5 degrees. But the angle I'm solving for is theta. So the next thing I need to do is I need to look over there, and you'll see that we have sine theta equals negative. So where is sine negative? Well, sine is positive in quad 1, so we're not looking in quad 1. Sine is positive in quad 2, so we're not looking in quad 2. However, sine is negative in quad 3 and quad 4. So in quad 3, my angle, which is only theta, very simple, will be 180 degrees plus my reference angle. All right, so if we take my reference angle and we add 180 degrees, we're going to get 197,5. So we don't need to see that written like that, as long as we understand that that's what we did. So let's just save a little bit of space here and write it out once. So 180 plus 17,5, so that's 197,5 degrees. However, if we think about it, remember what's been happening is what you've started with is a radius that starts there and then rotates all the way around until it has stopped in the third quadrant. But we could keep rotating my radius around and around and around indefinitely. In other words, we can keep coming back to the same spot in quadrant 3. Now, if you watch the way my pen is moving, it's moving through a total of 360 degrees. So to get the general solution, we're going to say plus K360. Now, it's important, I can't add on part of that 360 degrees. I can only add on a whole amount of 360 degrees, which is why you always see written K is an element of Z. And obviously the Z means integers. Remember, integers are positive and negative whole numbers. So you can add on any amount of 360 degrees as long as you're adding on whole amounts of 360. Or, we've currently only considered an option in the third quadrant, but we also said that sine theta is negative in the fourth quadrant. So theta could lie in the fourth quadrant. And if theta lay in the fourth quadrant, it would equal 360 degrees minus my reference angle, which is 17.5, and that gives me an angle of 342,5. Plus every 360 degrees, because I can keep going round indefinitely. So that's my general solution. If I wanted to narrow it down just to the first four quadrants, my answers would just be the 197,5 and the 342,5, third and fourth quad. Right, the next equation we have is 3/4 cos theta equals negative a half. Now the first thing I need to do here is I need to get rid of that 3/4. I need to isolate my cos theta. So to get cos theta on its own, what I need to do is to divide by 3/4. Now remember, dividing by 3/4 is the same as timesing by 4/3. So I'm going to expect you to do your arithmetic, because let's face it, some of us are not very good at that. So dividing by 3/4 is the same as timesing by 4/3, which is going to give me negative, the 2 and the 4 will cancel, 2/3. So cos theta equals negative 2/3. So I need to say to myself, well, where is cos negative? Now remember, your all stations to Claremont, so we know that cos is positive in the first quadrant, so obviously theta can't be there. Cos is positive in the fourth quadrant, so obviously theta can't be there. So theta must lie in quad 2 or quad 3. In quad 2, remember, it will always be 180 minus your reference angle. And in quad 3, it will always be 180 plus your reference angle. So what's obvious from this is that I need that reference angle. Now please remember, and this is what you guys always forget, when you're looking for your reference angle, ignore the negative sign. So you're going to type into your calculator shift cos 2/3, or 2 divided by 3. And that will give me an angle of 48,2 degrees. Now obviously 48,2 is in the first quadrant, and we said theta was not in the first quadrant, so that is my reference angle, it's not my answer. So if we go back and look at what we wrote down in the cast diagram, theta in the second quadrant is 180 minus the reference angle, which will give me 131,8 degrees, plus, if I want to keep coming back to that second quadrant, I want to add an amount. Now you might have had N360 in your textbook, K360, N360, doesn't make any difference, as long as you don't forget to write K's, or K is an element of integers on the right. Obviously, we also had the option for the third quadrant where we had to go 180 plus my reference angle. And that gives me 228,2 plus every 360. Right, in this next example, I want you to notice, just look at this carefully. 3 theta minus 8,7 is not in brackets. Go back and look at the previous page. Here, not really an issue. Your 3/4 was in front, so it was 3/4 times cos theta. Here we've got tan 3 theta minus 8,7. That minus 8,7 is not attached to the angle 3 theta. So the first thing we want to do is isolate that tan 3 theta. You may not divide by 3. Whatever you do, do not divide by 3. It is not tan times 3 times theta. It's tan of the angle 3 theta. So we're going to start off by isolating tan 3 theta. That means we're going to take that negative 8,7 to the other side, which will make it positive. So we've got nothing added or subtracted from tan of the angle. We've got nothing multiplied by tan of the angle. We just have tan of an angle equals 8,7. Now 8,7 is positive. And where is tan positive? Well, it's positive in quad 1 or quad 3. So if we're looking at quad 1, we're going to have 3 theta in quad 1. Alternatively, 3 theta could have been in quad 3. But before we worry about that, we obviously need our reference angle. So to find my reference angle again, we're going to go shift tan 8.7. Remember, you're looking for the angle, you use shift. And that's going to give me 83,4 degrees. Now remember, that is not theta. Do not divide by 3 at this point. You do not want to mess with your reference angle. Okay, we're finding not theta at this point, but 3 theta. Look at the cast diagram. Look what I've written in quad 1 and quad 3. I have written 3 theta, not theta. Now you have a choice here. You can either only worry about quad 1 and go plus k 180, which obviously if you're here and you add 180, it's going to take you to the third quad. That's up to you if you want to do that or not. Okay, some of you might like to play it safe and go in quad 1, go plus k360, and then again in quad 3 plus k360. Either way, you land up covering all the scenarios. I'm a maths teacher. I am predominantly lazy, so I'm just worrying about quad 1 and saying that in quad 1, if I have 3 theta, well, quad 1 is just an acute angle, so it's just equal to the reference angle. Now I'm going to go plus k 180, and that will take care of quad 3 at the same time. So this is the only place that you can do this, is when you've got a tan. Okay, there are some other circumstances, but as far as you guys are concerned, for this type of equation, if it's sine or cos, you're always going to go plus k360. If it's tan, you only need to worry about one quadrant and go plus k180. If it's too much to remember, do both quad 1 and quad 3 and plus k180. All right, now I want to know what theta is. So I've solved for 3 theta. Now I want to know what theta is. So I'm going to divide through by 3. That means I need to divide both 83,4 and k180 by 3. So we're going to get 27,8 degrees plus k60 degrees. And if you think about it graphically, the period of a tan graph is normally 180, hence plus k180. But if it was tan 3 theta, the period would be 180 divided by 3, which is 60. Okay, last example. This one really does cover all the sorts of things we need to worry about. Okay, here you cannot separate out parts of this angle, not until the very, very end. So you're not going to solve for theta until the last step. You're going to solve for that red bracket, that 2 theta minus 46. So the first thing I want to do is I want to isolate cos of that angle. So we're going to have cos of 2 theta minus 46. And we're going to divide by 7. That's how we're going to get rid of it. That's negative 5/7. Now, that means we have isolated cos with its angle. So at this point, we are ready to find my reference angle. And to find my reference angle, we're going shift cos. Do you want to include that negative? Of course not, because then you're not going to get a nice acute angle. Okay, and that's going to give me 44,4 degrees. Okay, my next step is to decide where is this big angle. Okay, well, cos is negative. We can see that over there. Cos is negative. So where is cos negative? Well, it's negative in the second and the third. In the second, my angle, which is that whole caboodle, 2 theta minus 46, will equal 180 minus your reference angle. And that is 135,6. Okay, so I'll say that again. It's second quadrant, so it's 180 minus the reference angle. So 180 minus 44.4 gives me 135,6 plus period of a cos graph, 360 degrees. As soon as you put that k, write down k as an element of z so you don't forget whole numbers only. I'm going to just leave 2 lines because I'm going to have to solve for theta. But my other option, my angle, which remember is not theta but 2 theta minus 46, could have been in quad 3. If it was in quad 3, it would be 180 plus the reference angle. So 180 plus 44.4. That gives me 224,4. Don't forget, plus every 360 degrees. All right. Now I'm going to go back and just solve for theta up here. Obviously, it's like you're solving a general grade 8 equation. So you want to move that 46 across. So 2 theta. And now when I move that minus 46 across, I obviously have to add it. Now I'm going to add it to the degrees, to the 135,6. Otherwise, you can't add it to K360 because that would be adding unlike terms. So 181,6 plus K360. Now I need to get rid of the 2 in front of the theta. That means I need to divide through by 2. So 181.5 divided by 2, which will give me 90,8. Plus, if you divide K360 by 8, you're going to get K180. Now, obviously, when you look at this, if you had to draw the graph of cos 2 theta minus 46, because it's a 2 theta, there would be a period change. Your period would be 180 instead of 360. All right, I need to go back and finish off in quad 3. So I'm going to first move that 46 across. So 224.4 plus the 46 gives me an angle of 270,4 plus every 360. I don't need to write k as an element of integers again. I've already got it. And lastly, divide through by 2. And voila, you're done. So these are your basic equations. You can't do these, you're going to be lost.